Hello, welcome student. And in the previous lectures, we are just to discuss the concept of electric potential. What is the electric potential? Electric potential, it is the work done to bringing of that unit charges which are comes from the infinity. Consider this is one of the charges plus q, and another one unit charges, that is q0, is bringing in the electric field surrounding these two positive charge plus q. From these charges comes from the infinity, and how much the work done, this work done is known as the electric potentials. And in these lectures we are started discussions of the relationship between the electric field and electric potentials. And firstly discuss what is the electric field. Electric field, consider one of the charges, this plus q charge, or the object which had certain charges, and the area surrounding these charges is known as the electric field. Field, it means area. This area surrounding the electric charges, this is called as the electric field. And in this lectures we are started discussions of the relationship between the electric field and electric potential. Relation between electric field and electric potential. Electric field and electric potential. Electric potential, it is the work done by the charges, by the unit charges which are bring in the electric field from the infinity. And the electric field, it is the field, it is the area which are present around the charged object, around the charge. This is known as these both definitions of the electric field as well as electric potential. Consider the one of the electric charges, that is a plus q, is one electric charges which are placed at a point O, and according to around these charges, or due to these positive charges, they produce certain electric field. That is, consider electric field E is produced by the positive charge plus q, which are situated or kept at point O. Kept at a point. We are consider one of the positive charge plus q which are situated at the point O, and the electric field is produced due to these positive charge. This positive charge, and one another unit positive charge, that is plus q0. This is the unit positive charge which are placed at a point n. They are placed at a point n. Let's join between these O2 and O is the positive charge, plus q is the main positive charge, and this plus q0 is also a positive charge, but this is the unit positive charge. That is, plus q0 is a unit positive charge. This is the unit positive charge, and this unit positive charge comes towards to the come towards to this positive charge. This unit positive charge is comes towards to the this positive charge. This unit positive charge which are situated in the electric field, which are produced by this positive charge, and they are comes at certain point after some times at the certain point m, and due to the position changes. What is the change of position is known as displacement, and this unit positive charge displaces a smallest distance, that is dx. This unit positive charge is displaced towards to the plus positive charge towards to the O, and they come towards to plus q charge, that is positive plus positive charge. These charges, the unit positive charges comes towards to the plus q charges, and that is displacement, and certain displacement that is dx. Dx is the smallest displacement which are covered by the unit positive charge which are comes towards to the positive charge which are always situated at a point O, and when at the time of they cover certain distance or they displace or travels towards to the plus q charge positive charge, they cover certain displacement, that is smallest displacement dx from the point n to the point n. The produced electric field आपल्याला बघायचं काय, the relationship between the electric field and electric potential. The electric potential is a v and electric field is a e, and we want to find the we want to find the relationship between the electric potential and electric field. Electric potential is a must be work done, and work done is a force into displacement. In these lectures we got a hint, we want to find the displacement which are used to finding the work done. And what we are discussed, we are discussed the electric potential and electric field. Electric field also had certain, electric field is also had certain distance, and the electric distance certain directions. The directions of the electric field is outward directions. It is E bar is going outward direction from the field. Then the direction of electric field E bar is outward directions from the positive charge which are situated, which are kept at a point O. This is all about the certain explanations about the our diagrammatic representations or our two different charges which are placed in a linearly. Now we know that when the charges will be carried, they have certain force. This force is known as electrostatic force. The force of the charges is known as electrostatic force. And we know that the directions of the displacement is towards to the plus q charges, that is positive charges, and electric direction of electric field is opposite to that dx. It means electric field, direction of electric field, and the motions of the positive charges, unit positive charges, opposite to each others. As the electrostatic force along the E, the electrostatic force is along the E, we want to find the work done. Electrostatic force along, that's E. Then the work done is equal to work done equal to force into displacement. Work done is into force into displace. This is the definitions, or this is the formula to finding the work done. And we know that work done is also the electric potential energy or electric potential. I will draw the smallest charges, positive charge plus q. We know that dw, work done, is equal to force into displacement. This displacement is displaced by the unit positive charge towards to the, and f in the form of electric field. When we are studying the electrostatic, this force is a electrostatic force. This force is a electrostatic force. And the electrostatic force, electric, due to the electric field, they are opposite to each other. The displacement as well as electric field, it means electrostatic force, are opposite to each other. Then the dw is equal to minus e into dx. This O is the point. dw is equal to minus e into dx because the displacement is opposite to the electric field. Displacement is opposite direction to the electric field. We know that dw is also the dv. It means dv is equal to dw is also equal to, sorry, dw, it means work done is equal to dv into smallest charge, unit charge. Then they had a unit charge having the value is 1, multiply with any numbers. 1 is multiply with the any number that doesn't changes in that numbers. It means work done is must be equal to the work done. And the electric potential is also one of the work done, and this is also one of the work done. Then this must be equal to dv only, because now dw equal to dv. dw is a work done, and dv it is the smallest potentials of that charges which are displaced, the smallest displacement, that is dx. Now the dw equal to dv, then this dv is must be equal to minus e into dx. Now let's calculate. Then the dv is equal to minus e into dx. We want to find the relationship between the potential, electric potential and electric field. Then this dx is multiplied with the electric field when they are going opposite directions or opposite sides of the equality sign, they get divided. Then E is equal to minus dv divided by dx. This is our required equations which will be find the relationship between the electric field and electric potentials. Okay, just take a screenshot for revisions. Now just to revise what we are discussing, relationship between the electric field and electric potentials, electric field as well as electric potential. We know that the electric field is produced around the charges, around the positive charges or around the charge object. And the electric potential, it is the work done to bringing that smallest charges or that unit charges that comes from the infinity to the electric field. Then consider we taken a electric field. This electric field is produced by these positive charge. Certain electric field is around these charges due to the these charges, and these also plus q positive charges are placed at a point o, and q0 is the unit positive charge. Q0 is the unit positive charge, and this unit positive charge in the range of the electric field which are produced due to this positive charge. And next, and these q0 charges are bringing towards to the q positive q charges, towards to the positive q charges which are always placed at a point o, and the displaced, they are when they are moving there's certain displacement, and this displacement is dx, and the directions of electric field, this displacement is a dx. The directions of electric field, it means this direction, the direction of electric field is outward directions between these two systems. And electrostatic force, we want to dealing with the electric field, the relationship between the electric field and electric potential. Electric field, it means the certain forces acting on that charges. These charges is known as electrostatic charges. They are along the e bar, it is the electric field. Then the work done is equal to force into displacement. Work done is force into displacement. Then the work done is equal to force into displacement. The force acting on these charges, which are must be displaced at the smallest displacement, that is dx. Then this force is known as the electrostatic force, that is E bar. Then this electrostatic force, this work done is also equal to the dv, and dw is equal to work done at its potential energy into the smallest charges. कुणावर झालेला आहे स्मॉलेस्ट चार्जेस, पोटेन्शियल ऑफ या चार्जेसचा पोटेन्शियल, त्या चार्जेस मध्ये काहीतरी पोटेन्शियल आहे, तो काय करत आहे त्याच्यात जवळ यायचा प्रयत्न करतोय. म्हणजे हा पोटेन्शियल झाला आणि हा चार्ज म्हणजे त्या चार्जेसवर झालेला काहीतरी वर्क डन. But जो काही चार्ज आहे, this charges is a unit charges, they had a value is 1, it means dw is equal to dv. It means dw is equal to dv, and this dw, this is the value of dw in this equation. We can notate this equation as a 1. Then dv is equal to minus e into dx. We want to find the relationship between the potential and this is electric field, then E is equal to minus dV by dx. This is the direct relations, negative direct relations between the electric field and electric potentials. And one concept which are discussed in this topic, that is electric zero potential. Zero electric potential or zero potential. What is about the zero potential? Zero potential, it means zero potential. The potentials, we are taken one of the reference. We want to comparison between the two different charges, potential between the two different charges. One is a plus q1, another is plus q2. We want to compare between the potentials of these two charges, but these are certain largest displacement, or they are situated between the largest. One is situated at a point O, another is situated at a point it is P. Consider this is point P and this is point O. These are both are in a different way of place, or they are different. But we want to take one of the hypothetical reference point. Hypothetically reference point, that is the we are consider this hypothetical reference point as a R, and the potential at the point is must be a zero potential. It is not any value at the potential of this point, and then we are compare between these two potential from these points. This is known as zero potential. Zero potential, it is mean one of the hypothetical reference potentials we want to take for the comparison between the potential, electric potential between two different charges. This is all about the relationship between electric field and electric potential, as well as smallest zero potential. This is the smallest concept, easy concept to explain, or easy concept to understand, that is the zero potentials. In the book they are had certain complicated language. Okay, we are stopping.